Dear participants, it's my pleasure to present this topic on the use of timber in high-rise building structures. My name is Boris Azinović. I am affiliated at the Slovenian Building and Civil Engineering Institute. This contribution was prepared in cooperation with my colleague Istok Šuštaršić from the Inner Renew Center of Excellence. This presentation consists of 5 main points. First, I will present some facts on sustainability concerns of the construction sector. Then I will present different types of building structures, followed by the world trends of high-rise timber buildings and some Slovenian examples. In the end, a few challenges in design of timber buildings in practice will be exposed. So the construction industry is the top global consumer of raw materials. The industry generates between 25 to 40% of the world's carbon emissions and approximately 50% of all solid waste. This volume of natural resource utilization is not sustainable and could compromise the environment for the sake of growth. Additionally, the increase of population in urban community poses a growing challenge to the construction industry. Achieving targets for global carbon dioxide emission reduction demands smart planning and sustainable design, which could reduce energy consumption and pollution. Well, one of the possible solutions for more sustainable design of buildings is the use of timber. Timber is one of the building construction materials that is poised to make rapid advances in the next decade or so through prefabrication. It's easy to install and generates almost no waste. On the sustainability side, timber can lower a building's carbon footprint by sequestering the CO2 used during construction. Integrated into prefabricated building construction, the timber can be used in a closed-loop cycle. The timber offcuts from the manufacturing can be used to power the manufacturing plant, and when buildings are demolished, the carbon can still be stored in reused or recycled materials. Compared to traditional construction, procurement of timber elements require a greater level of coordination earlier in the design process. Prefabrication of panels in a factory offers accuracy and quality, optimizing material use while vastly reducing site waste, and therefore, all in all, is a well-suited material. So now let's look at some of the possible options of timber building structures. The first use of timber in modern housing was assembly with logs into a so-called log house. More advanced structures which are being used mainly for low-rise timber buildings are light timber frame structures. Furthermore, it's possible to resist lateral loads by using moment-resisting frames around the perimeter of the building. Then finally, the approach which is most commonly used in Europe is with cross-laminated timber or CLT walls and floors. Cross-laminated timber is a building material that was developed some 25 years ago. It consists of a number of solid timber boards which are glued or nailed together crosswise. Then in recent years, several high-rise building structures were constructed where timber elements were only a part of the load-bearing system. Such buildings are considered as hybrid buildings, where particularly combinations with reinforced concrete and steel are possible. In the next section, we have prepared a quick overview of the already constructed timber and hybrid building structures. On the picture above is the Mjostrnet 18-story building with moment-resisting frames and CLT walls and floors. This structure was finished last year and is located in Norway. Starting chronologically, one of the first high-rise buildings with cross-laminated timber was constructed in London in 2009. Another hybrid building with CLT was a 6-story apartment building in Berlin. constructed in 2011 was the Limnologen in Sweden, which is a combination of CLT and light timber frame structure. Then there's a 9-story hybrid building in Milan, constructed in 2013. 10-story CLT building in Melbourne. 14-story treat building in Norway with glue-line mega frame around the perimeter of the building. And some of the more recent, the 10-story apartment complex in London, and 18-story hybrid Brock Commons building in Canada. As seen from the brief overview, multi-story timber construction has evolved tremendously during recent years. An important factor has been the development and wide acceptance of CLT as a reliable, efficient, sustainable, and versatile material. On the above graph, it's clearly evident that the worldwide production in volume of CLT has risen almost exponentially. The latter is in close correlation with the trend of constructing timber buildings. The slide above is intended to show the development of high-rise timber and hybrid buildings. Some buildings with asterisk are shown as concepts or planned buildings. So hopefully we'll be able to say in the future that this trend was followed and that our newly constructed high-rise buildings will indeed be more sustainable. Well, the use of wood as a structural material, however, often results in the introduction of other materials to achieve certain performance requirements. For example, concrete is often used to achieve acceptable floor vibration, then gypsum boards for fire resistance. Then furthermore, critical elements of the design of most timber structures are the connections between load-bearing elements, which in most cases are steel or adhesive. Figure on the right shows the proportions of materials in a series of timber and hybrid buildings. It can be seen that there's often a substantial mass of concrete integrated in the building due to several reasons which are not just structural. Since this event is hosted in Slovenia, I'd like to show a few examples of multi-story timber buildings constructed in our country. Till now, the timber buildings were, let's say, limited to mid-rise structures to 5 stories. Shown above is the Karantanica building finished in 2018. It has a concrete base and 4 stories in CLT. Then there's a building in Polje with 5 stories where the ground floor is made of reinforced concrete and 4 stories above from CLT. There's another CLT building, the Squashland, finished in 2018. The Ultima commercial building in Komenda finished in 2012. It's worth mentioning that it was constructed only in 2 months. One possibility is that I haven't mentioned yet today, but my colleagues have, are the upgrades with timber structures. In 2010, vertical upgrade with 2 additional stories was performed in Terme Čatež. The additional timber structure is lightweight, and therefore no strengthening of the existing masonry structure was necessary. So for the last section, I'd like to show you some of the challenges in the design of timber buildings. One of the key points is definitely the protection of the main load-bearing elements against moisture. When exposed to wetting, wood is prone to degradation, microbial and fungal attack, and of course larger deformation. Secondly, fire danger is always top of mind when considering a timber structure, especially since it's a combustible material classified in Euro Class D. During fire, steel connections are the typical point of failure, not the load-bearing elements itself. The natural process of charring during a fire actually serves to protect the structural integrity of the material. This is not an open and shut case, however, and the discussion around this topic continues. It's worth mentioning that the fire regulations usually govern the number of stories. Then furthermore, acoustic behavior is also a major concern, mainly due to the relatively low specific weight of timber structures. Problematic are all aspects of noise protection, airborne noise, structure-borne noise, and impact noise. Then in many European countries and worldwide, there's a high level of earthquake hazard, so that earthquake loading is a key factor influencing the design of buildings. This issue is important also for high-rise timber buildings. In general, we could say that these structures are lightweight, which is beneficial in case of earthquake loads. However, the response of mass timber structures is often rigid, characterized by brittle failure. Therefore, the design and development of dissipative connections for such buildings is crucial. Another issue worth mentioning is also that hybrid structures are, by their definition, asymmetrical in their floor plan. Well, the low mass of timber structures may be beneficial for seismic, however, on the other hand, not for wind. Ultimate limit state is usually not the problem, but serviceability limit state is, as the accelerations can surpass the code prescribed limits. Counteractions include stiffening the structure or increasing the mass of the structure on the top, installing tuner active mass dampers. The current research is focused in measuring existing timber buildings, comparing the results to finite element models, and evaluating more precise damping values for different construction types and boundary conditions. Well, this was all from my side. I hope I was able to promote constructing with timber a bit in this forum.
Thank you very much.